I am Jawed Ahmad, Department of Mathematics, Jamshedpur Women's College, Jamshedpur. In this video, we shall try to understand the concept of neighborhood of a point with the help of different examples. Now, let us first see what the definition of neighborhood of a point says. A set X, which is a subset of R, where R is the set of real numbers, is called the neighborhood of a point A belongs to X if there exists an open interval I containing the point A and contained in set X, and symbolically this is expressed as A belongs to I, which is a subset of X. And now let us see the concept of neighborhood of a point with the help of different examples. First, we take a finite set. Let A is equal to the set which contains 0, -1, 2, 4, 5 as its members. For a given epsilon greater than 0, however small, there exists an open interval 2 minus epsilon, 2 plus epsilon, such that 2 belongs to 2 minus epsilon, 2 plus epsilon, which is not a subset of A. Arbitrarily, we have taken a point 2 and whose endpoints 2 minus epsilon, 2 plus epsilon forms an open interval and whose member is 2, and this is not a subset of A. Why? Open interval is an infinite set. An infinite set cannot be a subset of finite set. This implies by definition that A is not neighborhood of its point 2. Similarly, we can prove that A is not the neighborhood of any of its point. This question can also be solved by taking any arbitrary point X of the set A, and you can show that X belongs to X minus epsilon, X plus epsilon, which is not a subset of A, because between two any real numbers there are infinity of real numbers. An infinite set cannot be subset of finite. And this example justifies that every finite set is not neighborhood of any of its point. Now let us consider an infinite set, and you students are familiar from the set of natural numbers, which is an infinite set, and a set of natural numbers contains 1, 2, 3, 4 and so on as its member. And first we check whether n is the neighborhood of any point, say 3 or not. For example, we have taken 3 as a member, and as earlier 3 belongs to 3 minus epsilon, 3 plus epsilon, which is an open interval and not subset of n. Actually, the open interval whose endpoints are 3 minus epsilon, 3 plus epsilon is an infinite set. An infinite set can be a subset of another infinite set, but here between the two real numbers there are infinity of real numbers, and each real number needs not to be a natural number. That is, every member of this open interval is not the natural number, and so it is not a member of n, and as a whole this open interval is not a subset of n. And we have explained these things in writing, and you can say easily that n is not a neighborhood of the point 3, and by taking x as an arbitrary member of this set of natural number, you can show that x belongs to x minus epsilon, x plus epsilon, which is not a subset of n. That is, there exists an open interval containing x which is not a subset of n, and by definition this implies that n is not the neighborhood of any of its point. In the next example, we prove that the set Q of rational numbers is not the neighborhood of any of its points. Like before, you can take any rational number. For example, 2 by 3 belongs to Q, where Q is the set of rational numbers, and there exists an open interval containing 2 by 3 whose end points are 2 by 3 minus epsilon, 2 by 3 plus epsilon, and which is not a proper subset of Q. By the similar arguments, you can say that between these two real numbers there are infinity of real numbers, and each real number needs not to be a rational number. That is, between these two real numbers there are infinity of irrational numbers which are not the members of Q. So we can say that the set Q, the set of rational numbers, is not the neighborhood of any of its points, but the set R of real numbers can easily be shown that it is the neighborhood of each of its points. Next example, and a question like this can be asked from you students, that show that open interval is the neighborhood of each of its points. Let us take an open interval whose endpoints are a and b, is an open interval, and let CD be two numbers such that a is less than c is less than x, and x is less than d is less than b. Because between the endpoints a and b there are infinity of real points, and we have taken c and d, any two real numbers between a and b, such that a is less than c is less than x, and x is less than d is less than b, and this concept can be easily understood with the help of number line. That is, between a and b, c and d are any 2 points, and x is any arbitrary point between c and d, so that we have a less than c is less than x is less than d is less than b, implies x belongs to the open interval CD, which is a proper subset of open interval AB. So we see that there exists an open interval containing x and is contained in the open interval AB. So the open interval AB by definition is a neighborhood of the point x, and it can be generalized that open interval AB is the neighborhood of any of its point, but closed interval AB is the neighborhood of each of its points excluding its endpoints a and b, because A belongs to A minus epsilon, A plus epsilon does not subset of closed interval AB, and B belongs to the open interval B minus epsilon, B plus epsilon, which is again not a subset of closed interval AB, and you can say that the closed interval AB is the neighborhood of each of its points between A and B, excluding the endpoints A and B. Stay home, stay safe, and stay connected, and we shall meet again in the next video. Thank you.